All right, I guess we're going to go ahead and get started. My name is Dave Thaler. This is my friend Kushal. We're developers in the Windows Networking department at Microsoft. And we're here to talk about connected applications. So I want to ask a couple questions first. How many of you guys were at Build last year down in Anaheim? Okay. Fair number of you, about, I don't know, maybe a third to a half of you. Okay, great. By the way, did anybody come and see my talk? I gave the talk on sockets last year. Anybody? Okay, only one of you is spoiled for the demo. Okay, because one of my demos is a continuation of the demo from last time, so you may recognize it and it'll be new to everybody else. Okay, great. So let's go ahead and get started. So we're going to talk about primarily four things today. Okay, by the time that you leave, you're going to learn how to use a technology called Wi-Fi Direct to discover nearby application instances. Okay, for example, multiplayer games. Anybody here thinking of or creating a multiplayer game, some sort? A couple gaming guys? Okay, great. We're going to talk about some tips on creating a great experience for your connected application. You're going to learn how to easily connect streams and how to secure connections with a minimum of effort using SSL and TLS. So those are the things we're going to concentrate on today. Now, the overall message is the same as last year, which is that Windows 8 and the APIs that we have make basic networking easier. Okay, and we'll go through an example or two of that. Enables new scenarios, and we'll start off with one new scenario. And has cross-language support. So the thing I want you to keep in mind is even though I'll be using C# and some of the sample code, okay, all of the things that we're talking about work in any of the languages. We're also going to use JavaScript in one of the languages here. But whether you're using Visual Basic or C# or C++ or JavaScript, everything we're talking about applies to all those languages. Now, last year, we gave a couple of talks from networking. Okay? 3 of those examples are on the slide here. The second one is the one that I did last year about sockets applications. But these are the 3 talks from last year that are probably the most relevant to what we're talking about today. Okay? And so here, this is my plug for, if you haven't seen the stuff online, okay, anybody that was not at Build last year, anybody watched some of the episodes online? Okay? They're all there. Okay, Channel 9, MSDN, you can go and you can watch all these talks here. What I'm not going to do is I'm not going to be repeating information that we talked about last year. Okay, what I'm going to focus on today is things that are in addition to what we talked about last year. Okay, and we got a number of questions last year. We've been watching the forums and pulled in a number of questions. And so what we did is we pulled out some of the most frequently asked questions and some of the things that we did not talk about last year. And that's what we're going to focus on today, is answering those questions, showing you some tips and tricks of things that have come up since last year. So with that, let's go ahead and get started. Now, most Windows Store applications, okay, we found are connected in some sense. That means they use the network or the internet in some way. Okay. More and more, this is the trend, even if it's just like a simple game, right? It may use the network for leaderboards or for the high scores and that kind of thing. Okay. But the majority of applications tend to be using the network in some way, and that's what we mean by a connected app, right? Just something that happens to be using the network to retrieve content, to publish information, to call some REST API, whatever it is. So we're going to start by showing you an application that any of you who were at Build last year, right, got those little tablets, and on there was an application called Word Hunt. And this is what I used in my demo last year for you in the back that was there. So over here, this is an example of the Word Hunt application that I'm going to use here. And you can see there's just a grid of tiles. And we're looking for words. We have law and rears and so on. Okay, so this is a nice single-player experience, right? So far, this is not using the network. Okay. But it can be fun, right? You're probably all staring at it, finding words. Anybody see a great word in here? No? Is everybody awake yet? Okay, no, it's early in the morning. Okay. Somebody yell out a word. Okay. Okay, wars. Okay, great. Okay. Okay, here. Who yelled that out? Okay. Here's a candy for you. You can get it up last year. It's right up here. Okay. Did y'all have a good Halloween? Right. Got plenty of extra Halloween candy here. All right, so let's go ahead and switch back to the slides. So this was a single-player experience, okay? And we want to turn this one into a connected application. Okay? And in particular, I have my friend Kushal here, and I'd really like to play against him, right? Because I got my words, and I've got all you guys helping me out, right? But he's pretty good too, and so I want to see who's better, right? So let's talk about a technology that is new in Windows 8 called Local Area Wi-Fi Discovery. Underneath it uses something called Wi-Fi Direct. So that's what we're going to talk about here. So if we're going to discover somebody else to play a game with, or to say collaborate with in a collaborative editing experience or what have you, In order to initiate a connection to that machine or to that application, you have to discover the remote endpoint somehow. So there's this discovery problem you have to solve. How do I discover it? Because that can be complicated. So typical methods fall into about 4 categories. Okay. How have we been doing this over the last 10, 20 years? Okay. Well, there's the type in a hostname method. Okay. Well, what's the name of your machine? And I can type it in. And maybe I got a typo in there. Maybe I read it wrong or whatever. Second category is sort of server-based, right? And so if I was using, say, the Xbox Live SDK, I might be using a lobby or something to find people around the world that are interested in doing some activity. The tap experience is, I tap 2 machines together and using the NFC radio, and then that says, well, I found them by sort of physical proximity. And the last one is I can multicast or broadcast within the local area and look for people, say, in this room that might be playing or might be interested in playing the same thing, or collaborating, sharing the same experience. Now, typically this last one is within a LAN, okay, but we'll talk about that. So last year, we dove into the tap experience, and we showed how we added the tap experience into the WordHunt application. Okay? And if you want to see that part of the demo, you can see the video from Talk 580 from last year. So this year, we're going to focus on this one more. Okay? Now, the trick here is that typically within a LAN, okay, but what if I'm not connected? Okay? What if we're on different LANs? What if I'm on mobile broadband or not signed in at the time? Okay? So we're going to talk about how you don't have to be on the LAN at the beginning and still have a good experience. So as we go through this, there's 3 important concepts we want to keep in mind. Okay? 3 sort of levels of granularity. The first one is things that we want to discover. So a service. Okay? I want to discover all of the whatever. So in this case, it would be all of my apps. So my application here is the service. Okay? I want to discover my application that's out there. An instance is that service or that application running on a specific machine. Okay? So if there's 5 people running the application, there are 5 instances of the same service. Okay? And lastly, there's an endpoint. Right? A particular machine may have multiple IP addresses or ports or what have you. And when I actually can establish a connection, my connection is going to a single endpoint on that instance, or that instance may have many endpoints. Okay, so those are the concepts I'm going to use in this discussion. So Wi-Fi Direct is the technology that we're going to talk about underneath, okay, that allows you to discover and connect to other instances. So the discover step is you start as input, you have a service, which in this case is your application. Something that identifies your application, which, by the way, that's the default, and so the lack of an input is the same as that. And the output here is a set of instances. Now, each instance is represented by a peer information object in the Windows Networking Proximity namespace. Okay, so discover, I say, give me a set of instances or a set of peer information objects. Okay. Now that I have those instances, I want to connect, and so I want to connect to a specific instance, okay, a peer information object that represents one machine, which might have a collection of IP addresses, collection of endpoints. And what I get out of the connect is a session represented by a stream socket object. Now, of course, underneath, there's actually that socket is tied to a specific endpoint. Okay? Well, I didn't have to specify the endpoint in the APIs, but if I want to know the endpoint, I can look in the socket properties to pull out the remote address and remote port so I know which endpoint it was using. The point is you enumerate peer information objects, and then you connect to a specific peer information object, and what you get back is a socket. Okay. Now there's a sample, which is the proximity sample on MSDN, and you're welcome to use that as code to start from if you want to play around with this. So I'm going to use a C# example snippet here and walk us through what you might do. So in sockets-like applications, right, we often come at it from the perspective of there's one side that's the listener and one side that's the connector. Or the initiator. Okay? And so we're going to start from that perspective, and then we'll go one step farther. So on the listening side, here's what we might do. So the first step, because we're listening, okay, we want it to be discoverable by the clients, so to speak, is we can optionally set a display name. Okay? Now, the display name can be used when enumerating who's out there to play against. Okay. So in this case, we got some string that would be in the myNameToDisplay variable, and we set the display name property of the PeerFinder class. We then register a delegate in the connection requested event, and we say start to start advertising. So at this point, we're discoverable, and when the event is signaled, our delegate gets called, peer connection requested. And you can see the arguments has a peer information object as a property. That peer information object has a display name inside it. That's the display name that the other end set. And so here we might ask, we might prompt the user, do you actually want to play this game? So-and-so wants to connect to you. Do you want to do this? And the user can confirm. Right. Contrast this with the tap experience, where if you look at the presentation from last year, there was no such confirmation because this was a physical action. Right. I have to come within 4 centimeters, and it's the physical proximity that's the evidence that you actually want to accept. Okay. But here, since it could be anywhere in the room and I may or may not know you, then in this example, there's a specific confirmation step. And so that's what the display name is for. And then finally, we tell the peer finder to connect to the peer. So again, we pass back in the selected peer information object, and we get back a socket. Right? And at that point, we've got a connected socket, and we can go on with the actual game. So that's the listening side. Here's an example of the connecting side in C#. And all of the peer finder, peer information is, again, in the Windows Networking Proximity namespace. So we'll define a list of peer information objects to be used. Okay. Now here the initiator also sets a display name. Okay. And this can be used with a confirmation step that we saw in the previous slide. So-and-so wants to play a game with you, or wants to join your collaborative editing session, or whatever it is that you're doing. Okay. He then calls start and find all peers async. Now start here was also used, this is the same call as was used in the tap experience. Okay. So this illustrates that with the same code here, you can work with both the tap and this kind of browse type of experience to discover each other. Find all peers async is the function that returns the set of peer information objects. And this will do a scan, and it'll take about a second to complete. And at this point, it has a list of peer information objects. And each of them has a display name property. And so it might use that in some UI concept to say, how do I decide which one of those that I want to pick from? Okay. I found the following 3 guys in the vicinity. Which one of those do you want to use? And so I pick one, say peer list subindex, and pass that to peer finder connect async. So this is the same call as was on the previous page, right? They're both using connect async on a peer information object. Okay. And at this point, since this is the initiator and he's now in, he can be done with discovery, so we can call stop. So that experience showed 2 sides that were sort of implemented differently. Right? One side was the listener, and one side was the initiator. Okay. Now for things like a 2-player game, and here Word Hunt we turned into a 2-player game. Right. Trying to expose to the user, do you want to be the initiator or the connector or the initiator, can be something that is kind of more confusing than helpful for something like a 2-player experience. So often what's actually easier in the user experience is to have a symmetric experience, where the user isn't asked to make that choice and the app just works and everything happens under the covers. Okay. So we can simplify that and not ask the user by using a symmetric discovery experience. Okay. So now we're going to go back into Word Hunt, and we're going to show you what we did to Word Hunt to make it use a symmetric discovery experience. And Kushal is going to take us through that. Okay.
Okay. Can you hear me? Okay. So, Dave, do you want to play a game of Word Hunt?
Sure.
So
I got one of the tablets from last year's build. So.
Oh, so do you have the game running?
Okay, I'm going to collect multiplayer mode here. Looking for friends. Oh, I see you. Select opponent begin game. I see you, Kushal. Okay, so I'm going to select your name there. Starting game.
There you are. So let's play a game.
Okay. All right. Anybody see a good word? This one's harder, isn't it? How about games? We like games? Mast. Good one. Okay, you get it. Okay, so that's probably good enough, unless somebody sees a really long word. No. Okay.
Okay. So, any more?
Yeah.
Okay.
Show us how you did this, Kushal.
Okay. So, let's jump to the code and see how Word Hunt builds the symmetric experience Dave talked about. So Word Hunt is a JavaScript app, and Peer Finder API is available in JavaScript as well. It grabs the user. Let me full screen it. Okay. So it grabs the user profile information and takes the display name out of it. So that's and sets the display name property on Peer Finder. So you saw our names pop up in the UI. That gives a more personalized experience. Then it sets 2 event handlers. It sets an event handler for trigger, and it sets an event handler for connection requested. What that does is the app is designed for both tap and browse, and user has a choice to do both or either. So after that, it calls PeerFinder start, and that means the app instance is discoverable. And then here's the interesting thing. So it does one find automatically without user's action. What it does is it pre-populates a list if people are already in their multiplayer lobbies. And you saw that when I entered the multiplayer lobby, I didn't find, but when Dave entered the multiplayer lobby second, he found me and he could initiate the connection. So fewer clicks and a simpler connection setup experience. So this find is a wrapper that we in this code. Find calls the asynchronous API on PeerFinder, find all peers async. This API completes with a peer information collection. Each entry in this collection is a peer information object. It's the app instance. It has the display name property, and it just takes that collection and populates the UI. It creates an entry for each user. When there is an incoming connection request, the connection requested event handler does something similar. It grabs the peer information object from the event arguments and then highlights the entry in the UI. And then either ways, the user selects the peer either to initiate a connection or accept a connection. Both those code paths call into connect peer, and connect peer calls asynchronous API connect async that takes the peer information object, and it completes with a stream socket. At this point, the game can start. And that's it. It's very simple API to use this very cool technology.
Okay, great. Good. Switch back. Yeah, that's okay. Pretty cool, huh? Thank you, Kushal. So let's recap kind of what we've seen. Right, you saw the symmetric experience here was that there was no prompt to say, do you want to host a game or join a game? Right, it's whoever joined last tended to do the find all peers. So he did the find all peers first. I did one. I found him. I joined him. Right, it could have gone either way. Whoever joined last was the initiator in this example. Okay, so this was kind of the symmetric experience that we talked about. So let's talk about some things that may or may not have been obvious here. Okay. So it was a display name. This is where my name showed up here. Okay, you can see it was using my personal name as the display name. Okay, now that display name should be a unique string. Right? I don't know if there's any other Dave Thaler's in this room, but probably not. Right? Here it was pretty unique. But if I went to a family reunion, my father's name is also Dave Thaler, and so maybe just showing that wouldn't have been sufficient if I was doing some family reunion game. Right? So you might want to think about, what do I use there? Do I need to put some disambiguator at the end, like number 1 or number 2 or something, to disambiguate when I get collisions or something? Okay. Now this defaults, if you don't fill in the display name property, it defaults to the machine name. Okay. But you might use a username or a gamer tag or the machine name or whatever. Okay. Now the thing to think about here, the tip, is that when you submit something to the Windows Store, you have to have a privacy policy. Okay. And keep in mind that whatever you put in the display name is broadcast in the local vicinity. Okay, so whatever you pick here, you probably want to think about how you'd want to phrase that in your privacy policy, because you're saying whatever you're going to put in that display name, maybe you prompt the user to say what would you like to put in there, whatever it is. But think about that when crafting your privacy policy, to say that that information is going to be revealed within the local vicinity. Okay. So we talked about the user experience with the start method, making it and how Kushal walked through and showed 2 event handlers being registered, one for the tap event, one for the browse event. It makes it really easy to, at the API level, to support both tap and browse. And so think about when designing user experience, is it going to be really easy to support both? Okay. Well, one thing to think about is, what message would you tell the user to do? Do you tell the user to tap? Do you tell them to look in the local vicinity? What's the message that you put on the screen to sort of introduce your connected application? Okay. Because if you are on, say, a desktop machine with no NFC radio, you might not want to have a tap message that's on there. Okay. Or if you're on some other class of machine that doesn't have Wi-Fi Direct, you might not want to have that type of message. So if you want to pay attention, there's a supported discovery types property of PeerFinder that can tell you, has a flag for which ones are actually supported in the hardware of the machine that you're running on. Okay. So you could use this, for example, to tailor what message that you're going to display on the screen to tell the user what to do. Okay. So all that support is there. 2 other things. You can only connect to one peer at a time due to the way the radio and the driver and things work. So that means that if your application is running and it's connected in one of these Wi-Fi Direct sessions, and by the way, this does not disconnect you from the internet, so you may be connected to whatever your normal network is, as well as the Wi-Fi Direct network that you've established here. But you can only be connected to one Wi-Fi Direct network at a time. And so what that means, for example, is that if your application, if somebody puts it in the background to go and do something else, Okay? And then it brings it back in. By the time you come back in, it may have gone down because the other application may have just taken over. Right? So it's the last one wins. Okay? And so what that means is if you're being resumed or you're coming back into the foreground, you should be prepared to reconnect. Now, in the word hunt game that we were playing here, you see the multiplayer game. I don't know if you noticed this, but the word hunt game, the multiplayer version, there's a countdown timer. It was like 3 minutes. Okay? And so for something like that, it probably wouldn't make sense to reconnect to the same session because your 3 minutes would have been elapsed or whatever. And for that type of experience, we'd probably start over. But for something like a collaborative editing session, we want to reconnect back into the same session. And so that may affect how you design your user experience. So just be prepared to reconnect if you lose the foreground. And then lastly, the Wi-Fi Direct driver can't advertise and discover at the same time, which means while Find All Peers is running, right, it's actually not discoverable by the other side, right, because the radio can only either scan or advertise, but not at the same time. Okay? And so if you want the symmetric user experience where the user doesn't know which one it is, right, what you don't want to do is you don't just want to call Find All Peers in an infinite loop. Right? Don't do that because it'll always be discovering and never advertising. Okay? And so if you need to do that, then make sure you introduce something like a random delay. Now in the experience that we showed, okay, it was the last one entered wins, and so there was no need to refresh or call it more than once. Okay? But if Kushal was, say, in the next room over, started it, and then came into range here, okay, then that Find All Peers might have already completed, and he might have needed to use the refresh button there. But for most of the experience here, that would not have been necessary. Okay, and as you saw in our demo, we never used a refresh. Okay, so that's the end of the Wi-Fi Direct portion. This is kind of the new feature, new experience that you can use to discover other instances to make yourself be a connected application within a local area. So let's move on to the next section about tips for writing connected applications in general. All right, there's many different APIs that use networking in some way. There's a white paper that we put on MSDN. You can go and search for this, or you can go and download these slides afterwards and click on the link here called Developing Connected Applications. And right now that white paper covers 4 main tips: picking the right API, picking the right capabilities, adapting behavior for metered networks, and reacting to network status changes. Now, all 4 of these were covered at length last year. This one we talked about in Talk 580. This one was in 588, and those 2 were in 785. Okay? So I'm not going to repeat all the information that's in there, except for I'm going to briefly touch on number 3 just because there's been a lot of discussion about it recently. So what you don't want to do is you don't want to be the reason your customers get bill shock. Right? Bill shock is when they suddenly get their bill and it's an order of magnitude larger than they expected. And it's because something was consuming a whole bunch of bandwidth that they didn't expect. Right? You don't want to be that app. Okay? So how can you avoid that? Okay, so here's the overall guidance, and we talked about this last year as well. Okay, but I'm going to repeat it now in case there's questions at the end. There's a property called connection cost that has a couple of properties here that are important. So there's a network cost type that's part of that. And that is one of the 4 values, unrestricted, fixed, variable, or unknown, that says, am I paying per byte? Am I under a cap? Am I just party on because it's free Ethernet like here at the conference? Roaming is a Boolean, whether you're outside your home provider or not. So let's say I'm on a mobile broadband connection, LTE or something, and I'm out of my home area. An over data limit, whether I'm already past my cap and I'm now, say, paying per byte. So that's the information we provide that you can consume in whatever way that you want. There's some suggestions for how you might use those, which is many applications can have 2 or maybe 3 different modes of operation of some sort. Okay? And think about what this means for your application. So the first mode might be just normal, everything's fine, just use the network however you want. Okay? And that's perfectly appropriate when the network cost type is unrestricted and roaming is false. You might have a conservative mode where I'm, say, consuming less data. Maybe I'm using lower resolution images or sending fewer frames or something like that. Some degraded experience that still provides some connected experience, but maybe not as high resolution or high quality or as fast. Okay? And so you might use a conservative experience if the network cost type is fixed or variable, which means there is, in fact, some cap that you're going towards, but you're not roaming or you're not over your data limit. Okay? then the last one is, well, you're actually roaming or over your data limit, and so you know you're paying per byte. Okay? And so there, the recommendation is don't do anything unless the user opts in. Right? Don't surprise the user. Let him know that you're going to be paying for stuff potentially, or you're over your limit, or you're roaming. Do you really want to do this? And if he says yes, then you can party on, but then he's opted in, and there won't be bill shock. Okay? So those are three kind of modes, and not all three make sense for all applications, but many of those make sense for many applications. So think about that and use these properties at the top to decide which mode that you want to be in your application. Okay. And this is, again, independent of which API that you're using. Whether you're using HTTP or sockets or anything else, the same behavior applies. Okay. These are properties that are not properties specific to any API. They're just generic properties of the machine. So I talked about how the white paper has 4 sections right now. We're in the process of revising it to add some stuff, and so I'm going to cover what we're adding to it. So things that were not in the original tips that we're putting in. The first one is to be power efficient. Okay. Now we talked about being cost efficient. Okay. Being power efficient has a lot of the same properties because it turns out that bandwidth consumes power. Okay. The more bandwidth you use, the more battery that gets drained, or the more electricity on AC that gets used. Keeping the radio up less means less power. So the same guidance as before also just happens to be the same for power. But there are 2 things that are worth noting. Okay. The first one has to do with caching of content, and the second one has to do with avoiding frequent periodic messages. So let's walk through those. Well, caching is a well-known technique. You say, yeah, everybody knows about caching. Okay. Well, what's interesting here is that some APIs do caching for you, and some the application is responsible for the caching. Okay. And it's useful to know which is which, so you know whether you get it for free or whether you got to do something, right? So the top ones here, Windows Web Syndication, which is RSS feeds and that kind of thing, and XHR and storage file, say accessing stuff across SMB, all have caching under the covers. Okay, you use those, you just get caching. Okay. Now actually syndication is configurable by the application, but the default is of course to use caching. Okay. For other APIs, right, the application is in control of the cache. That unless you do something, you don't get a cache by default, you have to do something. Okay. So HTTP client and background transfer are examples there. So background transfer, for example, the application says download this file and put it in this particular directory. Okay. So the application is in control of where the content is and thus in control of whether it's cached. Okay. Now, of course, caching not only helps you conserve bandwidth and power, but it also provides a better user experience because of the latency issue, right? If it's cached, I don't have to wait for it, right? So that's good all around. But just knowing which APIs do caching and which don't is kind of the tip here. Okay, frequent periodic messages. Now, it turns out that the wireless radios, whether we're talking about mobile broadband radios like 3G, 4G, or whether we're talking about Wi-Fi, they tend to have this notion of a higher power state and a lower power state. Okay. So we know it takes more power to, say, transmit and so on. But just what power state that it's in, the way that they usually work, and again, this is up to the hardware, and it varies by link type, and it varies by driver, but they all have this notion in general of after some idle period, then they drop to a lower power state. Okay. And so if you're doing stuff very frequently, then it'll stay in the high power state because the transitions can be expensive in the driver. Okay. So they'll have this kind of idle period. So what would be inefficient, okay, now of course there are sometimes you have to do this, but you should be aware that it's inefficient from a power perspective. If you're sending messages that say every 30 seconds, periodically, what happens here is, the driver might get to a state that says, well, I've been idle for 25 seconds here. It's now a good time to drop to a lower power state. It's doing that, and you send a message, and it comes right back up. Okay? So that means it's never really spending any time with the lower power state, because it doesn't even start until, let's say, 30 seconds after the last message that you sent. Okay? So frequent periodic messages keep it from going to a lower power state and thus consume more power. Okay? So the tip here is that if you can, if it makes sense for your application, batch stuff, do a whole lot of stuff at the same time, and then leave longer idle periods, if that makes sense. Okay? Because it's the longer periods that give you the battery savings. And if your intent is to, I just want a notification channel so that I can get inbound notifications and I have to keep this thing up all the time, consider using the WNS push notification service, and there's a talk 863 from last time if that applies to you. Okay. So that's the tips just in general about how to conserve power and how to conserve cost. Our next section is talking about how we make the basic networking experience easier. And we're going to talk about this notion of streams. There's many things in Windows that use the common concept or common language or term of a stream. They're all implemented as a stream. So there's a set of things that are input streams, like cameras and microphones and sockets and files. There's a set of output streams, which are sockets and files, but also things like speakers and video controls. Okay? They all speak the same term of input stream, output stream, random access stream, that kind of thing. And so this makes it easy to say, take input from a webcam and stick it into a socket. Or take information from one of these and put it in, socket to file or whatever. You can also have this section that's called filters, which have both an input stream and an output stream, and it does some conversion, like compression or encryption or so on. And since that also uses streams, it's easy to stick them in the middle and create a pipeline, such as from a socket through decryption and then off to a video control. Or from a microphone, compress it, send it across a socket, and so on. You get the idea. So here's an example of using copy async, because it turns out that we've made this really easy for you to connect the streams without having to worry about the threading model and the buffering and am I starving the pipeline or how does this work. Okay. So here we're trying to go from a socket to a file. Okay. So we have a connected socket and we've got a file that's open. Or we've got a file. So we open the file, read write here, so that we can have an output stream. So I have a connected socket and we have a file stream. There's a method on the random access stream that's called copy async. You can see we pass in the input stream, and the file stream happens to be a random access stream, and so we can pass that in and it'll get the output stream from it. So with one line of code here, it constructs the pipeline that just goes off as an asynchronous operation, and it does it for you. Okay? So this connecting the streams here, instead of having to write lots of buffering code and threading code and so on, now you can do it in a single line of code. Okay? Is that cool? Yeah? Great. It's okay to clap if you want. So. All right. Okay, just making sure you guys are still awake. Okay. So let's say we want to insert one of the filters in there. Let's say we want to insert a decompression filter in the middle. How would we change this? Okay, so we have our old code from down below, and we're going to insert a decompression filter. So here, again, we're sticking in one line of code. This one creates a decompressor that wraps the input stream. You see we're passing the input stream into the constructor of the decompressor. So we've got a decompressor object that wraps the input stream, and we've changed copy async to pass in the decompressor. That's it. Now we've got a two-stage pipeline going, and we did it by only adding one line of code. Okay, now with just two lines of code, we open it and we say, create us a decompressor that wraps the input stream, and call copy async, and copy async handles the whole pipeline now. Okay, cool? That's a lot of code if I didn't have copy async, right? Probably some of us have written code that tries to do this kind of thing, and it can be a lot of code, right? Okay, here's a decryption example. Here I've got a socket going to a file through a decryptor. So we open up the file. Here we're creating a decryption or a data protection provider. Now here the data protection provider is a class that does both encryption and decryption. Okay, and here since we're just using decryption, we're not passing anything into the constructor. And that's because the decryptor will automatically sense what the decryption algorithm is needed. If this was an encryption example, we would have had to tell it what encryption mechanism or what encryption algorithm to use. So here we tell the decryption provider or the data protection provider unprotect stream. That's the decrypt call to say decrypt this asynchronously. We pass in the input stream and the file stream. So here we're telling the decrypt object, here's the socket, here's the file, go. Okay. So again, one line of code to do the whole pipeline. Okay? See how easy it is? We tried to make this pipeline because everything uses input streams and output streams. Try to make this notion of pipelining as simple as possible because it's such a common operation. All right, let's move on to security. Okay, how do we secure connections? Well, SSL or TLS are supported by many APIs in the system. Some examples at the sockets layer, we have things like the socket protection level that you can use when creating a socket to set that to be SSL. You can put it on a socket that's already connected with upgrade to SSL async. Then there's things like WebSockets and XHR and background transfer that all use URIs. Right? And with URIs, it's just the letter S at the end of the scheme. Right? It's the WSS or the HTTPS that says to use SSL. Okay? So there's just one letter as opposed to a separate call. Right? Things that use URIs. Now, if we use those, they'll use SSL. So, why isn't SSL more popular today, right? Why do we have all these websites that are using HTTP and not HTTPS today, right? So let me ask, how many of you guys actually consume or provide REST APIs? Okay. Large portion of you. Okay. Rhetorical question, but you know the answer. Are those HTTP or HTTPS right now? Okay. Some of them are HTTPS, some of them are HTTP. Why is that? But if it's not HTTPS right now, why is that? Think about that. If it is, good for you, or good for whoever's providing it. Okay. So often the two excuses for why everything isn't SSL already, two of the main ones are, well, it's really hard for me to provision or time consuming, or I don't know how to provision the server with a certificate. Okay, I got to go off to some certificate authority, and I got to get that, and I got to install it somehow, and that's just too hard or too expensive or whatever it is, right? So that's one class of excuse. And so I'm going to show you how to use self-signed certs to make that be really easy, and we'll talk about that in a second here. And the second excuse is, well, it's really hard to code the client because I got all this S-channel stuff, and it's a lot of code and so on. So it's really hard to use, unless of course you're using one of the URI-based ones, in which case it's just the S, right? So Windows 8 also makes that really easy. So let's see how easy. So we're going to switch over here. And in this case, I'm going to go ahead and... So what I have here is I have a machine that has installed the HTTP client sampler right off of MSDN. Okay. The sample has... I'm going to go ahead and run this. The sample also comes with a setup script for an IIS server. And so that's also been run. So this just says I've installed it, I followed the instructions to set it up, and now I'm running it just like you could do on any machine right now. Okay. This is the sample as it is, and you can see if I click Start here, it's got this URL here that's in the address bar. This is sending off to the server. The server script has a 2-second delay, and then it sends back some content. Okay, so you can see here's the headers it got, and here's the content that it dynamically generated. Okay. Now, of course, this one's using HTTP. And what would happen if I put an S in there? Well, I'm going to get back an error message that says it's not listening on port 443. Okay, right here, actively refused it on 443. Right, not there. Okay, so we want that to work. So how do we do that? So we're going to go into the IIS manager. Okay, search for IIS right there. So we'll bring that one up. So this is our server side. Down here, there's a server certificates. Where did we go there? Okay, so here we are on server certificates. Right over here on the right, I don't know if you can see this here, it says create self-signed certificate. Can everybody see that? It's kind of small in the back there. Okay, right over there in the top corner is self-signed certificate. So we're going to click on that one. Select a friendly name for the certificate. So we'll just say my demo certificate. Okay. So we're going to create that one. And so now we've got a server certificate that's been created, that's self-signed. It has the name, this is the name of the machine here, build 3-127 is my machine name. That'll become important in a little bit. So now I can go into the sites. Here's my default website, and over here is bindings. Okay, if I look in this, you can see it's only listening on port 80. I have to tell it to listen on port 443. So I say add, type HTTPS, and down here I select an SSL certificate. There's my demo certificate that I just created. Okay, so I'm telling him to use the server certificate of my demo certificate. There we go. Now my IIS server is using that. Okay, but my application doesn't know anything about that yet. So I'm going to go into the certificates settings, and we see manage computer certificates. Okay. So here, trusted root certification authorities, certificates, and under friendly name, we have right in here my demo certificate. That's the one that I just created. I can right-click all tasks export. Okay, because what I want is I want to get the public key out of there. Okay, the certificate has a public key and a private key, and I want to get the public key out of it. I'm going to click next, and it says, do I want to export the private key? No, that's the default. I just want the public key. Here I got two different formats. I can use DER or I can use base64. Okay, either one, I'm just going to leave it as the default for this one. You might use base64. Here, I'm just going to put it on the desktop here, and we're going to call this my demo certificate. Okay, so this is creating a .cer file on my desktop. Finish. Okay, I'm done. Now I'm going to go back to my client, which is there. Okay. All right. So think about what we've done so far. So far, we've configured the server, okay, but we haven't configured the client. And if my client was on a different machine right now, it still wouldn't know anything about that certificate. Okay. But what I'm going to do now is I'm going to take that certificate, and I want that certificate to be used in my application. How many lines of code do you think it will take me to use that certificate? I see a person with 1. Anybody? 1? 1? Okay, we'll see how good you are. Okay. Under the app manifest, if I look in the declarations section, there's a certificates. So I say add. Now down here under certificates, there's add new. The store name, now this is important. I type in root, and then I select the file, which I saved on my desktop. And so we have my demo certificate. There it is. Okay. Now also I'll mention up here, there's a flag here that's called exclusive trust. Okay. So the question here is, do I want my client application to only use that certificate and ignore all other trusted routes? Or is this in addition to the other trusted routes that are part of the normal machine? Okay. So if I'm writing, say, a client that talks to my own REST API or a very specific REST API, I don't care about all the other trusted routes. I only care about the one for the service that I'm talking to. Okay? So if I want to be ultra secure and only talk to one site, say the one with a certificate that I just created, I click exclusive trust, and this is going to be the most secure because now I'm isolated from anything that might happen to those other trusted routes. Okay? If I'm doing this in addition to a bunch of other sites that I'm talking to, then I want to leave this one clear. So I'm going to check this one to say use only this cert and ignore all other certs on the machine. Okay? So this might be I'm creating a REST client. I've got my own server that's exposing the APIs, and so I've put the cert on the server side, and I'm taking my client application to use the certificate that I just created myself, and I'm embedding it into the client application. Okay? So now this is in there. Okay? And if I look at the Solution Explorer here, you'll see that when I added it, it got copied into my project. Right? It's no longer on my desktop. Well, it is, but the copy that's part of my project is in my project directory. So it took care of copying it into there and adding it up for me. Okay? So now if I run this, let's restart it here and we'll run it. Okay, here's the same application. Now how many lines of code have we changed so far? 0. Okay, good. All right, so we're going to stick an S in here. Okay, and now this one is going to fail. And this one is because you see the term localhost up here? It's saying the certificate is invalid according to the validation procedure. The name here doesn't match the name on the certificate. Okay, remember I said it was going to become important in a few minutes? Okay, the name I would put into here has to be the name that's in the certificate, which was build-3-127. Okay? So this is the name. Normally on a server that was running this would be a fully qualified domain name, and the fully qualified domain name would be in the certificate. But here, this machine I haven't configured a domain name on. I've only configured a host name on. Right? So when I constructed the certificate, there's no dots in it. Okay? But in a real application or a real server, you'd have the fully qualified name here. Okay? So now when I run this one, there you go. Secure. Okay. So again, I did this with 0 lines of code. So those of you who said 1 were not right for this particular one. Now in a real application, you see here I was typing in the URL. In a real application, you probably have this hard-coded. If I was going to be doing a REST API client or something, there'd be a line of code where I changed the S. And so you were half right, you get half credit. Okay? Because I would have put in the S someplace. Right? Okay, so you can still get partial credit for the guys that said 1 line of code. But the point is, it's so easy because it was 0 lines of code. Okay? Now here I was doing this in a test application. So you can use this notion of self-signed certificates to just test between your own stuff in the test lab without having to get a certificate. But I could also use this in deployment. Right? If I actually had a server and I had a client that I was shipping, and I was shipping both sides, I can construct a self-signed certificate, ship it in my client application, and it'll talk across the internet and be perfectly secure. And I didn't have to talk to anybody else to do that. Okay? So that's how easy it is to use a server-side certificate if you're just trying to do it with your own application. And you see here I was doing this with HTTP. I could have done this with sockets or with any of those other APIs that we talked about. Okay? Because the notion of the app manifest that we showed there wasn't an HTTP portion. That was just a generic, here's certificates that can be used by the APIs that this application calls. Okay? So it's really, really easy. Okay. So let's finish up our last section here by talking about loopback, which is probably the most frequently asked question from last year. So let me start by explaining a little bit of our philosophy, and you'll see that, where that goes to. Okay? We want you guys to make money. We all want to make money. Okay? One way to make money is to sell stuff through the Windows Store. The Windows Store applications, or the Windows Store, okay, we want consumers to have confidence in the applications they buy from there. It's a reason to go to the store as opposed to some other place to buy applications from, or to get applications from. So the more confidence they have in the store, the applications they get from there, the more they want to come back there to find those applications, okay, instead of giving up and going someplace else. Okay. So it's a property of the Windows Store that there's this confidence notion. And what does this then lead to? Okay. Well, confidence, what does that mean? Well, it's more of a user perception thing. Do they feel that it's safe, or have they had bad experiences with things? You know, has something happened to their hard drive, or who knows what? Okay. And so what we did from the Windows Store perspective is we created ways to safely interact with the rest of the system. And of course, classic desktop applications, meaning ones distributed through any other mechanism besides the Windows Store, still have access to everything that Windows can do. Okay? They can still do the less safe things. But that means if a Windows Store distributed application and a classic application can talk to each other, then the Windows Store application has a backdoor to do things that are the less safe things. Okay? So that's the Windows Store policies are to try to prevent that. And as a result, the desktop applications and the Windows Store applications aren't allowed to talk to each other. And this is not a property of the Windows OS. It's not a property of the APIs. It's a property of the store certification process. Okay? And so we'll talk about that in just a second here. So this means that, you know, all the different forms of IPC are blocked. In that blocked sense, that means when you try to submit it to the store certification will fail. Okay? But if you need to do that kind of stuff, that's fine. You just continue using a desktop application. You don't have to submit it through the Windows Store. We still like all the other apps too, all the other distribution mechanisms. But for testing, right? So, well, then how do I use, Fiddler? How do I use applications? Do I have to construct two machines just to test stuff? Well, if you think about the demos that we just showed, I just showed you the security demo. I was running IIS on the same machine, okay, as I was running that HTTP client sample on. That was on the same machine, and that was a Windows Store application talking to a desktop application in the demo that I just showed you. Okay. How did that work? Okay. Well, here is the store certification that won't accept it. Okay. I didn't submit this to the store right now. So what happens here is that on the local machine, when you're running Visual Studio plumbs an exception for you. So I didn't even have to show that in my demo. It just happened automatically. Okay. It said when I built the HTTP client sample, it said that can talk to loopback stuff on the local machine because I built it from Visual Studio. Okay. So that happens automatically, but you can also do that manually. There's a tool called CheckNet Isolation. Okay. And we talked about this in last year's talk 588 as to how to use this. So if you want to see what exceptions have already been done for me, right, I could type in this command line and I could dump all the things that this application, all the applications that are permitted to do loopback. Okay. So I can manually add them, manually delete them. You can party on. Okay. And so there's a MSDN article and there's a talk from last year that can give you information on how to do that. But the point is, you can test on the local machine. That's fine. It's not anyway intended to prevent you from testing all those things, all the tools and things you can do. There's also other cases that loopback works for. Okay? Loopback within an application, like two sockets within the same application, that also works great. The word hunt demo that we showed you at the beginning also used loopback. Okay? That one had a connecting socket, initiating socket, and a listening socket in the same app. Okay? When we were doing the two-player demo, one side constructed the board, okay, and the other side connected, but the side that constructed the board also connected back as a client. So the host, if you will, saw there as being two client connections. So there was a loopback connection between the two sides for whichever side had constructed the board. So that worked also perfectly fine. So loopback within an application is not blocked for anything. And lastly, loopback between two desktop applications also works perfectly fine because they weren't submitted to the Windows Store. All the networking APIs that we've talked about are not just for Windows Store apps. All the networking APIs work perfectly fine for classic desktop applications. If you're constructing classic desktop apps, feel free to use them. Feel free to use them with loopback. Works fine. The only restriction on loopback is the store certification process. Okay? Everything else you have control over, or it just happens to work. So let's review. Here's the 5 things that we've talked about. We've talked about using Wi-Fi Direct to do that peer discovery, and this is the word hunt demo that we showed you, the two-player game. Using appropriate APIs and timer intervals for power efficiency. This is the discussion of caching and which ones do caching for you and trying to batch stuff. We talked about how copy async and APIs like that make it really, really easy to connect streams so that you don't have to deal with all the pipelining and threading issues and starvation and so on. We talked about how to use self-signed certificates, either for testing purposes or in real deployment, to easily secure connections, to just make SSL be simple. And lastly, we talked about how to use checknut isolation to configure and view the loopback properties of applications. Okay? So with that, this slide just has a list of all the sessions that I've pointed to throughout the talk and all of the MSDN papers that have been pointed to throughout the talk. Okay? Just kind of all on one slide. And then here's your usual resources and stuff. So at this point, I'm going to open it up to questions. We've got about 10 minutes or just under for questions, probably. So go ahead. Thank you. Thank you. Thank you. Okay, so let's take some questions. Back here. Actually, we have 2 floor mics up here. If it's not a problem, come up there. Otherwise, you have to yell it out and I'll repeat it. Okay. Okay, the question is Wi-Fi Direct interoperable with other platforms besides Windows 8? The answer is yes. When I say yes with a caveat, okay? The Wi-Fi Direct protocol underneath is a standard, right? The metadata that we're exposing over the top, okay, is something that is a Windows value add, but it's something that can be interoperable. It just means that you may need to write code on the other platforms to consume that. Okay? And so there's something that we didn't show you that's a property if you search for the term alternate identities. It's inside the PeerFinder class of stuff, alternate identities. Okay? I mentioned that by default, it's your application that you fill in. If you want to search for and discover things other than your application ID in Windows, you use the alternate identities to say what other things you want to search for. And using alternate identities with whatever you've coded on the other ones, you can interoperate with the other ones. Anything you want to add, Kushal?
No.
Kushal is one of the developers on the Wi-Fi Direct stuff itself. So, okay. Will it work with Windows Phone? Same answer. Actually, you want?
So it'll work. It'll work over TAP.
Okay, that's right. Windows Phone has TAP, but it doesn't have the Wi-Fi Direct stuff at the moment. We got people at the line here, so you're number 4. So okay, go ahead.
Yeah. Are there any special additional capabilities you need to add when you use the additional, what was it, additional
alternate identities?
Alternate identities ID, because we tried that yesterday at the hackathon and we couldn't get it to work between the Windows 8 device and the Windows Phone. They just wouldn't never find each other.
The Windows Phone doesn't support the Wi-Fi Direct protocol at the moment.
Yeah, we tried it with the NFC on both
yes.
devices. So
NFC has a separate capability. The NFC stuff has a capability that's called proximity, okay, and we showed that in Talk 580 from last time. But yes, there's a capability that's specifically called proximity, and you got to click that one for it to be able to consume NFC.
Yeah, well, that was enabled, but we just never got it to work. So,
okay, maybe we can take a look offline. Yeah.
Any idea how to get an app certified in the store when it's using Wi-Fi communications between a Windows Phone app and a Windows Store app, but the store cannot test the Windows Phone app because it's not in the App Store, because they need to test every bit of functionality in the Windows Store app, but yet you can't submit the Windows Phone app because there's nothing for it to test or connect to, because the Windows Store app isn't in the Windows Store because it can't get certified. It's this endless loop of trying to get these things to work together.
Yeah, that's a great question. I don't know the answer. Do you know the answer to that one?
No.
Let's follow up offline when we have somebody from the Windows Store team in that discussion. So,
okay.
I'll give you 2 ways to follow up. You can either come and we're going to be over in Rainier right after this, and we'll see if there's a Windows Store person. But also tomorrow at 12:45. Okay, there's an Ask the Expert session where there's a bunch of networking folks there, and so there will be like 6 of us up on stage, and so somebody there might also know the answer. So if you want to come back at 12:45 tomorrow, you can ask that question again, and maybe somebody there will know the answer. So
okay,
either of those.
Thanks.
Something about beta? You can publish a beta. Okay. Talk to this guy here. He may have the answer for you.
Hi. So, two questions. First, so the loopback blocking, does that just block 127.0.0.1, or does it actually block, if you figure out what your local IP address is, or, worse, figure out what your external IP address is and you're behind a hairpinning NAT? Could it block that, or would that be?
It is not specific to 127.0.0.1. It's all methods of loopback. So it's not just networking, okay, but it's all of your IP addresses and networking and all the other IPC mechanisms. Okay.
So the other question I had is, so on when you're saying about the obviously try to keep your keep alives infrequent. What is recommended? Let's say you have like a Find Your Friends instant messaging app, and you want to show, okay, which of my friends are online right now, and if if each of them is only isn't have constant, hey, I'm still alive, ping is going to my server, I can't show which of them are still alive, which of them have gone into a tunnel or whatever. Mm-hmm. So do you have is there any recommendation for what's the best power efficient way to do that?
Probably, if it works for you, the number one recommendation would be try to use the push notification service to say, just use, say, raw notifications or something that comes through the one notification channel. Because that one already tries to optimize for the correct keep alive interval to send them as infrequently as possible but still work.
Does the push notification channel have some way of saying, can I successfully push to this other person right now or they're offline? Does the push notification channel have some way that I can say, if my server tries to push to this other person, will it work right? Is it likely to work right now?
I think what I was trying to get across is you can have presence notifications that come down to say, if I want to show that the presence change, say somebody just went away or somebody went offline, you still have to have a server that is responsible for sending those information.
I'm actually asking him, where does that server get the information about the other guy who's also on a Windows phone to know he's offline if he's not doing...
Okay, I understand your question. Let me think about that. Come and talk to me over in Rainier. Okay. I need more than 60 seconds to think about the answer to that one, but we'll have some recommendations.
Hi. Can the self-signing certificates work with Windows 7?
Can you self-sign certificates with Windows 7? Yes,
but you'll have to write a lot of code to...
No, I think the question was, does the IIS manager, does the server-side procedure that I showed here, is that something new in Windows 8, or did that exist in Windows 7 and the other classes of stuff? I think the answer is yes, it existed before.
So I can use the Windows 7 application also to connect with that? Because there's a lot of pushback from the SOX teams to kind of, the internal applications, make them HTTPS. So, okay.
Yeah. But the client-side stuff that we talked about, the integration to Visual Studio and the app manifest, all that is the Windows 8 stuff. But the server-side stuff is not new.
Okay, thanks.
It is just a little known, if you will, right? Okay. Any other questions? Okay. If not, we're going to go over to Rainier and hang out there for about a half an hour. And then again, I'll be back tomorrow at 12:45. Oh, that's right. You had a question.
You said it's working classic apps, correct?
Yes. How do you turn, when you say proximity, what do you mean?
Well,
do you mean?
Locating whether the computers are close to each other and stuff.
Okay. If your desktop machine has a wireless card, okay, then it's done with a Wi-Fi radio, whether it's within range. Right. The question was, how do you determine proximity with a desktop machine? And the answer is, well, the two proximity mechanisms that we have support for is the NFC radio, which is probably not in your desktop machine. Okay. You can get NFC dongles for desktop machines, but you'd have to get one. Not like they would be standard issue on most of them. Right. Exactly. Yeah, that's what cashiers would need. Or Wi-Fi radios, which are on desktop machines more and more now, right? And so you'd be using the Wi-Fi direct stuff that we talked about, and so it would just be wireless range. Okay. Thank you for coming. And I'll be over in Rainier, and I'll be in, I guess it's probably this room, I think, for 12:45 tomorrow. I'll look on your schedule.